Okay, and our last four verifications. In number 13, this side definitely looks like we could do much more work. So I'm going to make the left side my goal. So I'm going to rewrite the right side. And get to work. Let's see. I could change things into sine and cosine. What I do know about the cosine of 2x is that there's a minus that appears in the middle of all of them. So the cosine squared minus the sine squared, 2 times the cosine squared minus 1, or 1 minus 2 times the sine squared. So somehow, some way I know that I'm going to have to break apart that fraction into something minus something else. So I'm going to break it apart now. Okay, at this point, there are a couple of changes that we can make. Most likely, many of us would think, well, I could change things into terms of sine and cosine. So our cotangent is the cosine over the sine. And then our cosecant is 1 over the sine. The secant is 1 over the cosine. I can then multiply by the reciprocal for each. Let's see, these sines cancel. Cosine times cosine is cosine squared. In the second part, the cosines cancel, and sine times sine is the sine squared. And this is one of our double angle identities for the cosine of 2x. So we are done. All right, in 14, I personally like to take something that is 2 terms and write it as 1 term. There are certainly other ways that we could do this where we could take 1 term and break it apart into 2. But I'm going to take this side and rewrite it as the tangent squared times the sine squared. What I'm going to do is convert everything into terms of sine and cosine. That's one way. We could try to tie in Pythagorean identities somehow, but I'm going to change the sine squared into the cosine, or sine squared over the cosine squared. The sine squared will stay the same. Now what I can do is perform this mathematical operation to try to combine them into 1 term. We would know that we would have to find a common denominator. So sine squared of x over the cosine squared of x minus, we'll end up with sine squared times the cosine squared over the cosine squared. Then we factor out a sine squared. Well, at least that's what I think we need to do. I see that these both have a sine. There's really nothing else that we could do other than re-break this apart. That's not going to help us. So I'm going to try factoring out a sine squared. So if I factor out a sine squared, this becomes 1, and then this term would be left with a cosine squared. Now if I look at this multiplication, we could break it apart. And now I have the sine squared over the cosine squared of x, which is the tangent squared, times 1 minus the cosine squared is equivalent to the sine squared, with rewriting our Pythagorean theorem that sine squared plus cosine squared equals 1. 15 and 16. Personally, I think the ones that involve the sum and difference identities are easier verifications. All you need to know is that one identity, apply it, and start simplifying. So I know that I could rewrite this using that identity. So I'm going to make negative cosine of x my goal. So using my sum identity for the sine, it's going to be the sine of 270 times the cosine of x plus the sine of x times the cosine of 270. Now some of you might write it as the cosine of 270 times the sine of x. Fine. So it doesn't make a difference. So 270 degrees we have a value for. 270 degrees is the quadrantal angle between quadrant 3 and 4. And the point that we use here within our unit circle is 0, -1. So the sine is -1. The cosine of 270 is 0. So now I get negative cosine of x plus 0. So that just simplifies to the cosine of x. That checks out with our goal. Okay, 16. This side definitely looks like there's much more to work with. I'm going to make this side my goal. Okay, and let's see here. We have the sine. I'm going to start down here. The sine of x plus y plus the sine of y, sine of x minus y. Using our identity, we have the sine of x times the cosine of y plus the sine of y times the cosine of x plus the sine of x times the cosine of y minus the sine of y times the cosine of x. That's just using the sum and difference identities for the cosine, writing them out. So now when I look, I have the sine of x times the cosine of y here, and I also have it here. Both are positive, so they're like terms. We can add them. We have 2 of them. Now here I have a positive sine y times the cosine of x, and here I have a negative sine of y times the cosine of x. These cancel. So we're left with our goal.